Hi, this is Mr. Herman back with another video. This time we're talking about logistic growth functions and how they're different than exponential growth by having a limit. This one you see here, it says the spread of a disease is modeled by the following logistic growth function. And this particular one is one we did as a warm-up a couple days ago. So you can check back at that one and see it's the same one we did. Notice we got the 495,000 on top, and on the bottom we have 2 plus the 14.5e, that's our constant there, to the negative 0.196t. When you're doing this, remember you have to divide with parentheses, so we'll talk about that in a minute as we go through. Y is the number of infected people that you get, and T is the time in days. So let's look at these questions one at a time. You're going to have a question just like this on your test. So let's look at these one at a time, starting with A. So A says how many people are affected initially. We talk about a few different ways to do this. One way to do it would be to say at time T equals 0. We talked about when T equals 0 being the initial time, and then that gives your initial amount. So we take the calculator and put in 495,000 for this, divided by, and watch carefully how I put these parentheses and how I use them, because it won't work out right if you don't do it right in your calculator. 2 plus 14.5. Then you hit the e to the x button, and it looks like this. You get that e caret and then the parenthesis. Then you're going to put in negative 0.196 times 0. Then you're closing out the parenthesis right here for the e part. Then you need one more parenthesis for the end of the 2 division here. You can pause the video now if you want for a second and put that in. But you'll find that if you do that, you end up getting 300,000. Sorry, 300,000 people. We can find it another way also. Remember how this works is that if we take 0 right here, 0 times this amount here equals 0. And e to the 0, like anything except for 0 to the 0, is equal to 1. Then 1 times 14.5 is equal to 14.5, and 14.5 plus 2 is 16.5, which means I should be able to take 495,000 and just divide it by 16.5. And that should give me the same thing. Go ahead and try that in your calculator. And you see you still get 30,000 people. 300,000 again. I'm sorry, I think it is 30,000. I was wrong the first time. It's 30,000 people. Sorry about that. So you get 30,000. This should be 30,000 here. Sorry about that mistake. There we go. So you get the same thing both times if you do that. Now the next part says how many people will be infected after 3 weeks. So you're going to use the same expression you use right here, exactly the same for part B, except you're going to replace this 0 with a 21. Oops. So go into there now and put that a 21 in place of that right there. And what you really should do is just hit your back button and go up and delete these last few things, including the 0, and put a 21 and put them back in again. So this is where T equals 21. It's 21 because 3 weeks is 3 times 7 days, and that's the number of days is 21. When you do that, you'll put it in, you'll find you end up getting this amount here. It's 221,329 people, just like that. And I think it's actually got a decimal after it, but it's 0, so it doesn't end up being a problem. Then for last part C, for C we take and it says what's the maximum number of people that can be affected. Remember how this works with the maximum number? What you can do is you can put in a very large amount for T. So you can put in like 1,000 or 2,000 or 10,000, just try something large, and you'll find you get a maximum number. In this case, if I put, say, 1,000 or 2,000 in there, I get 247,500 people. And again, that's by just taking and putting in, say, 1,000 right here for T. The bigger the number it gets, it doesn't make a difference. At a certain point, it cuts off, and that's how logistic growth works. We talked about that. You could also take, if you remember how this works, the top part here, the 495,000, and you can divide that by just this number here. So whether you're dividing these here, we talked about this in class just today and yesterday too, divided by 2, and that'll also give you this same amount. So it's kind of a good double check. On the test, I suggest you do it both ways. Put it in as 0 for the first one for the initial amount, and then for the second part, divide it by the 14.5 plus 2, and then when it wants to know the maximum number, divide the 495,000 by the 2 only. So again, to find the initial amount, you can divide the 495,000 by the 2 plus 14.5. And to find the maximum number, divide the 495,000 by just the 2.